In the previous segments of our video lecture on cardiac electrophysiology, we have discussed how resting membrane potential is developed in both contractile myocardial cell and also in specialized myocardial cell. We have also seen how action potential is developed and how action potential is transmitted across the myocardium in both contractile myocardial cell as well as in specialized myocardial cell. Now, in addition to that, we also discussed how is the electrical voltage generated inside the cardiac cell is translated into mechanical effect or is translated into contraction of muscle by the contraction of muscular unit, which is sarcomere, which is called as electromechanical coupling. And finally, we have also seen the differences in waveforms of action potential in different cardiac tissues, including SA nodal tissues, AB nodal tissues, atrial myocardial cell, Purkinje cells, and ventricular myocardial cells. We have seen their differences, which all ion channels are involved, which all cells possess the property of automaticity or prepotential, which all cells has the plateau phase, and whose plateau phase is shorter, whose plateau phase is longer, which ion channels are involved in repolarization. We have discussed all those things. Now, in this segment, we will be discussing about the regulation of action potential. In the previous segments were the intrinsic activity of the myocardial cell. We now will be discussing how the external control or the external regulation by nerves and hormones will be influencing the action potential in the myocardial cells. So, to understand that, we know that the myocardium is supplied by autonomic nervous system. So, here we have autonomic nervous system. So, under autonomic nervous system, we understand that we have sympathetic fibers as well as parasympathetic fibers. Sympathetic supply to the heart is by 1. the cardiac nerve, the cardiac nerve which supplies the heart and which has or which releases the neurotransmitter of norepinephrine. And the second sympathetic connections are circulating catecholamines, which are released from the adrenal medulla. So circulating catecholamines, especially epinephrine. So whatever they may be, let it be norepinephrine or epinephrine, both of them will be acting on a special receptor on the heart, which is the beta 1 adrenergic receptor. So this beta 1 adrenergic receptors are the most abundantly found receptors in the heart. The heart also has alpha 1 receptors, alpha 2 receptors and beta 2 receptors, but the most abundantly found receptors are beta 1 receptors. So let it be norepinephrine through the cardiac nerves as neurotransmitters, or it be epinephrine through the circulating catecholamines they all will be affecting, all will be targeting the beta 1 adrenergic receptors on the surface of the heart, which will stimulate, which will give the heart with sympathetic stimulation. Now, we need to understand that where in the heart are beta 1 adrenergic receptors located. In the heart, beta 1 adrenergic receptors, we will be able to find them in almost all tissues. We have them in SA node, we have them in atrial myocardium, we have them in AV node, we have them in Purkinje cells, and we also have them in ventricular myocardium. So these, which means in almost all tissues of the heart, including the specialized myocardium and the contractile myocardium, beta 1 adrenergic receptors are abundantly present in all these tissues. Now, moving on to parasympathetic receptors, parasympathetic activity or parasympathetic connections. So parasympathetic connection on the heart is mainly by 1. The right vagus nerve, which is connected to the SA node, and we also have the left vagus nerve, which is connected to AV node. Now let's see, similar to the sympathetic circuit, we should also have a neurotransmitter substance. So the predominant neurotransmitter substance what we have here is acetylcholine. So acetylcholine is the neurotransmitter for parasympathetic nervous system. Now, which are all the tissues where we have these receptors? So before that, we have receptors. So receptors, in contrary to the beta 1 adrenergic receptors we have here in sympathetic system, here we have, yes, this is what we call as M2 muscarinic receptors. And these receptors are found mainly in SA node, then we have them in AV node. In SA node and AV node, we have these receptors in abundance, but contrary to what we have here in sympathetic system, where in all these tissues we have equal or abundant distribution of beta 1 adrenergic receptors, in atrial and ventricular myocardial tissues we have very less supply or presence of these receptors. So just to give you a recap, the electrical activity of the heart is also under autonomic nervous system regulation. Now, under which we have sympathetic and parasympathetic branches. We know the cardiac electrical potentials are regulated by the autonomic nervous system, under which we have sympathetic and parasympathetic branches. The sympathetic branch is through the cardiac nerve. The sympathetic control is through the cardiac nerve. The neurotransmitter is norepinephrine, and we also have circulating catecholamines released from the adrenal medulla, and here the hormone involved is epinephrine, and whatever may be the hormone, they will all access the target receptor, which is beta 1 adrenergic receptor, present abundantly in almost all tissues of the heart, including both specialized myocardial cells and contractile myocardial cells. So that is the summary of sympathetic component. Now moving towards the parasympathetic component, we have right vagus and left vagus supply to SA node and AV node respectively, and the common neurotransmitter here what we have is acetylcholine, and the receptor, in contrast to beta-1 adrenergic receptor in the sympathetic nervous system, the receptor what we have here is M2 muscarinic receptors, and these receptors, in contrast to sympathetic nervous system, the beta-1 adrenergic receptors are found in abundance in all these groups of cells, but here in parasympathetic system, these receptors are abundantly found in SA nodal and AV nodal tissue, but not very abundantly found, or is only scarcely found in other tissues. In ventricular tissue, especially in ventricular tissue, we don't have any kind of M2 receptors. Right? Okay. So from now, we have the idea of the distribution of parasympathetic and sympathetic fibers. What are their receptors? What are their neurotransmitters? And where do they act? Now let us see what effect these receptors have, activation of both these receptors have on both specialized myocardial cells and on contractile myocardial cells action potential.